Okay, today we are going to learn how to tell how many solutions a linear equation has. So we're going to solve each linear equation. I'm also going to teach you how to check to make sure that your answer is correct. So let's jump into it. Example 1 has given us 10x minus 47 equals 23, and we're going to solve for x, which is something that you've been doing a lot this school year, and then we're going to talk about how many solutions there are. So we're going to go ahead and add 47 to both sides because we're trying to isolate x, so we have to move everything away. So the 47 cancels on the left. I'm left with 10x is equal to 23 plus 47 gives me 70. And then to get x by itself, I'm going to divide both sides by 10, and I get x is equal to 7. So because I have a final solution of x equals 7, that means that this equation has one solution. So now, we can check to see if we're right. Every time you solve an equation, you can plug it back into your original number and see if it works. So I got my answer was x equals 7. So instead of x up here, I'm going to put a 7 in place of that. And so we can simplify this left-hand side and see if it actually equals 23. It should, because we should have gotten the right answer. So 10 times 7 gives me 70, and then I have minus 47. And then I'm going to put a little question mark over the equal sign because we want to know, is it equal to 23? If I did this in a calculator, I would get that 70 minus 47 is in fact 23. So you can see how we plugged in and we got that the left side is equal to the right side. So this checks and that's correct. Every time you solve an equation, you should get in the habit of doing this check to make sure that you're right. Because if you get to the bottom and you got, for example, 22 equals 23, those numbers aren't the same, then you would know you made a mistake. You could go back and fix it. Okay. Let's take a minute. I definitely want to make sure that you put some sort of a box or a highlight around this right here. When we solve equations, the answer that we get is our solution. And I want you to remember that the solution is just a number for x that makes the left side of our equation equal to the right side of the equation. That's what these solutions represent. Okay, let's look at a different example. For example 2, we've got 7x minus 3 equals 7x plus 5. So we want to get x on one side and numbers on the other. Typically we move the x's to the left. We don't have to every time, but we can do that this time. So to move this 7x over here, there's no negative sign in front of it, so that automatically makes it positive. So to move it, I have to subtract it from both sides. And I know that it's going to cancel on the right because that was the whole purpose of doing that. But over here on the left, I have a positive 7x minus 7x, and that is also going to cancel on the left. So my x term has disappeared. So all I have left is negative 3 equals 5. And I know that this is not true, and it will never be true. So that means that this equation has no solutions. All this means is that there is no number for x that I can plug in to make this equation true. There are no numbers for x. So how do we check this answer is correct? You pick a number, any number you want to. You pick something. Let's pick x equals 1, for example. I'm going to rewrite this in my original equation up here, but instead of writing x, I'm going to substitute 1 in. So I have 7, and then we substitute 1 for x, minus 3 equals 7, substitute 1 for x, plus 5. Now we simplify. So 7 minus 3, is it equal to 7 plus 5? Well, 7 minus 3 is 4. And 7 plus 5 is 12, and it's not true. You could plug in every number you could think of for x and run your check here, and it will never work because there is no possible number for x to make this original equation true, and that's what it means to have no solutions. Okay, last bit. Last example. 7x minus 3 equals negative 3 plus 7x. So we're going to work on getting x's on one side, numbers on the other. So I'm going to subtract 7x again. It's going to cancel on the right. I'm sure that we notice that it's canceling on the left as well. And all I'm left with is negative 3 equals negative 3. So because it's the same on both sides, that means that this is always true. Always true means that this equation has infinite solutions. And that means that every number you plug in will work. Every single x value you can think of will work in this original equation. So let's look. I'm going to pick x equals 3. You can pick any number. I actually will challenge you to pick a number different from mine and check it to see if it works. But I'm going to plug 3 in. So I have 7 times 3 minus 3 is equal to negative 3 plus 7, and then plug in my positive 3 there. So 7 times 3 is 21 minus 3 is equal to negative 3 plus 21. 21 minus 3 is 18. Negative 3 plus 21 is 18. It works. Any number you plug in, this will always work, always be true. So the reason we say it's infinite solutions is because there are an infinite number of numbers. Numbers go on forever. So every single number that exists can be plugged in. So there's one other way that you can write the answer, and it is something that we've already seen. It is all real numbers. So the solution, we have infinite solutions, and we would say the solution is all real numbers. I just want this to be something that you've written down and you've seen, because it's a possibility that it could show up on a test. Okay, so to summarize, when we have one solution, we solve our equation and we get x is equal to a number. When we have no solutions, we have a number equal to a number, and these numbers are not the same. Here, we're going to have a thing equal to a thing. It could be, I'm going to write, it's maybe number equals number. And we're going to say that both sides are identical. And let me take a moment just to show you what I mean by that. Up here at the top, for example, number 3, we had 7x minus 3 equals negative 3 plus 7x. I can take the right side here and take my two terms and flip-flop the order. And so if I take this positive 7x out to the front and this negative 3 afterwards, I can rewrite the right side so it's exactly identical to the left. And then we didn't have to do any of this solving part. You could just look at it and say, well, the 7x's are the same, the negative 3's are the same, so this is identical on both sides, which makes it have infinite solutions. So that's what I mean when I say both sides are identical. Sometimes you'll have something like 7 equals 7, or x equals x, or 7x minus 3 equals 7x minus 3. Anything like that is possible under our infinite solutions.